Here are the 6 AI trends that will matter the most in 2026. And this is not just my guess, but it is based on published research and reports from Microsoft and Stanford researchers, so let's go. The first one is the most interesting one for me, where entertainment is starting to change from us just passively watching to something that reacts to you and changes based on what you do. At Microsoft Research, Katja Hoffman, who leads the game intelligence team, describes it as a move away from passive consumers. So AI will make it possible to create experiences that adapt in real time while we're watching entertainment. We've actually seen versions of this shift before. We used to get news from TV and whatever broadcast companies decides to show us. But then the internet first came along, then we moved to subscription models where newsletters, blogs, Facebook feeds, you mostly hear from people that you choose to follow. Now we're sort of slaves to algorithms. According to YouTube, 80% of you don't even subscribe to my channel, so you're watching this video because YouTube recommended it to you. YouTube makes these guesses, which is the algorithm, based on what you have watched in the past, what you have clicked, how long you watched it, and how you react like clicking that like button. And by the way, you should hit that like button if you haven't already done it, so that algorithm understands that you're interested in content like this. Okay, now the next step is fully customized entertainment. So instead of a movie that's the same every time you watch it, you start getting stories that evolve. So characters can change over time as you watch. Storylines can respond differently depending on how you play or react to them. Black Mirror already played around with this idea, but only with a few different options. And generative AI will make it possible for there to be even more options. So the story might not even be finished when you're watching it. And in the past, this was done through preset options where you choose different options as you watch, but AI might start generating these dialogues and new scenes and directions on the fly based on how you respond. It feels kind of weird to think about how this is going to unfold because we haven't actually seen entertainment work this way, but that is the shift that's about to come. Entertainment that you get to participate in. Okay, the next big shift is about AI agents. Up until now, most AI has worked like a tool. You ask it a question and you get an answer back. Now we're moving away from that model, and instead of just answering questions, AI starts to take on full responsibility from beginning to end. So it's not just taking one step at a time, but managing the whole process for you. So let's say you're booking a meeting. Instead of just doing one step, imagine AI handling your entire calendar system. It might talk to the other participants, AI assistants to find the time, go back and forth to adjust things when things change, and set everything up seamlessly without you even checking a single message. At Microsoft Research, Salima Amarshi describes this as a shift toward autonomous agents that can collaborate, negotiate, and even make transactions on behalf of people and organizations. And the most important part is that it's not just one agent doing everything. There might be different agents handling planning, execution, verification, and monitoring. And they talk to each other to negotiate and correct each other. This is what researchers call agentic ecosystem. And these agents are designed to hold context over long periods of time, so not just one conversation, but weeks or even months of information. They can track your goals as they change. They remember decisions you made. So instead of AI tools that you just use once to get an answer, these teams of agents will become a part of your workflow. The next shift is moving away from the AI hype and into measurements. For a long time, the main question around AI was pretty simple. People wanted to know if it worked, like can it write things? Can you summarize information or answer questions in a way that's useful for me? But heading into 2026, that question feels outdated. Now the question is more about how well does it work and what is the cost and who is it good for? In other words, measurements are becoming more important. A Stanford professor, Eric Brynjolfsson, predicts that we're going to see what he calls AI economic dashboards. So instead of debating AI in abstract, these dashboards will track what is actually happening in real time. You can think of it kind of like checking the weather, but instead of temperature and rain, you're tracking the AI accuracy and productivity. It could even track things like which jobs are doing better, which ones are shrinking, and executives can start looking at AI the same way they already look at revenue or cost. Something tangible that's measurable rather than theoretical. These dashboards can update monthly or even daily, showing where AI is being helpful and where it's not. Companies are also being forced to become more transparent and honest about results. There's been some criticism that AI is not delivering large productivity gains yet, except for in certain very small areas. So we're going to start hearing more about where AI is failing, and that might sound bad, but it's actually a sign of progress. It's natural for any new technology to fail in the beginning, but when you start to understand it better, where AI works and where it doesn't, and what problems it's really good at solving, we can start seeing more and more improvement on AI productivity. We have seen similar patterns in the past, like when cars first came out, there were a lot of accidents because people didn't know how to drive correctly, how to drive along, or how cars can interact with pedestrians. But over time, we were able to understand what is the best way, what is the most optimal way for cars and humans to exist together. And now we cannot live without cars. So 2026 will be a transitional year where we figure these things out through measurement. And as we learn more and more about AI and its limitations, we will also start seeing them more in scientific research. At Microsoft Research, Peter Lee talks about AI becoming part of the discovery process itself. His view is that over time, every research scientist will have AI lab assistants that can suggest experiments and even run parts of them. And when we're talking about these assistants, it's way more than just searching papers or writing reports. AI will start to take part in the scientific method, helping researchers test ideas faster and explore directions they may not even have thought about before. But there's an important limit here. To be used in research, it's not enough for a model to be right, but we also need to understand how it got there. Because in science, you don't just want an answer, you want an insight. So there's increasing focus on what is called the archaeology of high-performing neural network. Researchers like Russ Altman are using tools called sparse autoencoders. These help you understand which pieces of data matter the most and how the AI performs. This will help us understand which pieces of data led to which parts of the answer. And when we start having more data transparencies like this, we can start using AI in science and research discoveries. Okay, but none of this works without the right infrastructure, which is the next shift. Today's AI models have to move huge amounts of data between GPUs and memory really fast, and doing that takes a lot of power. So the question becomes, how do you move data faster without burning so much energy? One answer is to use light instead of electricity. Costa expects 2026 to be the point where we start moving to more efficient compute models with low power optical fabric. Optical connections are faster, they use less power, and they can handle the kind of data these large models need. Once we have faster and more efficient infrastructure, AI will start running and improving its own systems. The next shift is AI moving into the physical world. Most people still think of AI as something that lives on a screen or in a chat box or a piece of software, but that view is already outdated with physical AI. At Microsoft, Ashley Lawrence uses this term to describe AI systems that don't just think or generate text, but actually control robots and physical machines. For the past decade, we have already been using robots. It's just been really good at repetitive tasks in controlled environment, like in factories, assembly lines, and warehouses, where everything is carefully organized. What's different now is the kind of AI being used to control them. Now we're seeing models that can see what's around them, understand languages better, and reason about what to do next so that they can act and react in the physical world. These are often called Vision Language Action Model, VLA. Instead of programming a robot with exact coordinates or step-by-step movement, you can give an instruction in plain language like put the red boxes on the top shelf, and robots will figure out how to do that on its own. The key point here is that they're not following scripts, but they're learning from past experience just like humans do. And they can also learn to adjust their behavior based on changes in the environment. Once we can do that better, we can start allowing robots to work in more real settings like at homes, outside of controlled environment. And personally, I can't wait for robots to do all the house chores for me.